In this video, we are going to discuss Newton Raphson method of solving algebraic equations of the type fx equals 0 by numerical method. Suppose x0 is the approximate root of this algebraic equation and let x0 plus h be the exact root of this equation, where this h is very small. If x0 plus h is the exact root, then we write f of x0 plus h equals 0. Now we can expand f of x0 plus h by Taylor series, which is f of x0 plus h equals f of x0 plus h f dash x0 plus h square upon 2 factorial f double dash x0 plus h cube upon 3 factorial f triple dash x0 plus so and so forth equals 0. Now, since this h is very small, we can neglect the terms involving h square upon 2 factorial f double dash x0 onwards because they are negligible. Now we write this f of x0 plus h f dash x0 equals f of x0 plus h, which is 0, so that h f dash x0 will be minus f of x0 and this small quantity h will be h equals minus f of x0 upon f dash x0, which means if we add this small quantity h equals minus f of x0 upon f dash x0 to this approximate root x0, we will get this exact root. So the next approximate root x1 will be the first approximate root x0 minus h, which is f of x0 upon f dash x0. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Effort has been made to explore the mathematical concepts through the basic ideas in mathematics. So, the first approximate root of the algebraic equation fx equals 0 is x1 equals x0 minus f of x0 upon f dash x0, where x0 is initial approximate root. Second approximate root x2 will be x1 minus f of x1 upon f dash of x1. Third approximate root x3 will be x2 minus f of x2 upon f dash of x2, so and so forth. So in general, n plus 1th approximate root will be xn minus f of xn upon f dash of xn, where n is 0, 1, 2, 3, so and so forth. And this is known as Newton Raphson method, and we have to use this formula to find successive approximate roots. Now we will try to understand Newton Raphson method geometrically. In xy coordinate system, let this be the curve of algebraic function fx. Let the curve cuts the x-axis at point A, whose x-coordinate is A, and exact root of algebraic equation fx equals 0 will be f of A equals 0. Let P x0 f of x0 be the point on the curve fx that will give initial approximate root x0 and f x0 on the y-axis here. Let us draw a tangent to this curve at point P, which cuts the x-axis at point x1. Here x1 is the first approximate root which goes nearer to the exact root A, which we write as x1 equals initial root x0, which is this, minus f of x0, which is this, upon f dash x0, which is the slope of the tangent f dash x0 to the curve at point P x0 f x0. Next, we will draw a vertical line through x1 which cuts the curve fx at point R, whose coordinates will be x1, comma f of x1. We will draw a tangent to this curve which cuts the x-axis at point x2, which is the second approximate root, still closer to the exact root A, and this we write according to Newton Raphson method as x2 equals this x1 minus f of x1, which we can find by drawing a horizontal line from R cutting the y-axis here upon f dash x1, which is the slope of this tangent f dash x1 at point R. If we repeat the same procedure for second approximate root x2, then we will get the third approximate root x3, which will be x2 minus f of x2 upon f dash x2. And this time this third approximation will be very close to the exact root A. To understand Newton Raphson method, let us solve a few examples. In the first example, we have to find the root of the equation 2x cubed minus 3x plus 4 equals 0. It is given that the roots of this equation lies between minus 2 and minus 1, and we have to take 3 iterations to find the root. First, we will confirm whether the root lies between minus 2 and minus 1. For that, let us first find out f of minus 2. That will be 2 minus 2 cube minus 3 into minus 2 plus 4. That will be 2 into minus 8 minus 16 plus 6 plus 4, which is minus 6. So f of minus 2 is negative. F of minus 1 will be 2 into minus 1 cube minus 3 into minus 1 plus 4. This will be minus 2 plus 3 plus 4. So f of minus 1 will be 5, which is positive. Now since fx changes sign as x moves from minus 2 to minus 1, it implies that one of the roots of this equation lies between minus 2 and minus 1. We start with the initial root x0 equals minus 1. Now we have fx equals this 2x cubed minus 3x plus 4, so that f dash x will be 6x square minus 3. We will use the formula x of n plus 1 equals xn minus f of xn upon f dash of xn, where n equals 0, 1, 2, 3, so on and so forth. Let us write the iterative formula by Newton Raphson method, which will be from this x of n plus 1 equals xn minus f of xn will be from this 2 xn cube minus 3 xn plus 4 upon f dash xn will be from this 6 xn square minus 3. This will be 6 xn square into xn 6 xn cube minus 3 into xn will be minus 3 xn minus 2 xn cube minus into minus plus 3 xn minus into plus minus 4 upon this LCM 6 xn square minus 3. This finally becomes xn plus 1 equals 6 xn cube minus 2 xn cube will be 4 xn cube minus 3 xn plus 3 xn will be 0 minus 4 upon 6 xn square minus 3. So we will use this iteration formula to calculate the 3 iterations. Now that we have the iterative formula xn equals 4xn cube minus 4 upon 6xn square minus 3, we will start our first iteration with base root x0 equals minus 1, so that the first iteration x1 will be 4 into minus 1 cube minus 4 upon 6 into minus 1 square minus 3. That will be minus 4 minus 8 upon 6 minus 3, 3. This will be minus 2.6667. For the second iteration, we will take x1 equals minus 2.6667 and find the second approximate root. X2 equals 4 times minus 2.6667 cube minus 4 upon 6 into minus 2.6667 square minus 3. That on calculator works out to be minus 2.0131. For the third iteration, we will take x2 equals minus 2.0131 and write the third approximate value x3 equals 4 into minus 2.0131 cube minus 4 upon 6 into minus 2.0131 square minus 3, which on calculator works out to be minus 1.7186. So after third approximation, we get the approximate root x3 equals minus 1.7186, which is very close to the exact root. In the next example, we have to find a positive root of x cube plus x minus 1 equals 0 by Newton Raphson method, correct to 3 decimal places. Here we have fx equals x cube plus x minus 1. Let's find f of 0. That will be 0 cube plus 0 minus 1 which is negative. Then we find f of 1, which will be 1 cube plus 1 minus 1. That will be 1, which is positive. Since fx changes sign from this 0 to this 1, we conclude that the root lies between 0 and 1. Now by Newton Raphson method, we have x of n plus 1 equals xn minus f of xn upon f dash of xn. This will be xn minus, from this, xn cube plus xn minus 1 upon f dash xn will be derivative of fx 3 xn square plus 1, which will be xn multiplied by 3xn square, 3xn cube plus xn into 1 xn minus xn cube minus into plus minus xn minus into minus plus 1 upon 3xn square plus 1. This will be 2xn cube, xn minus xn is 0, plus 1 upon 3xn square plus 1 equals xn plus 1. So this gives us the iterative formula for finding further iterations. Now for the first iteration, we will use the base root x0 equals this one, so that the first approximate root x1 will be 2 into 1 cube plus 1 upon 3 into 1 square plus 1. This will be 3 upon 4, 0.75. The algebraic equation that we have to solve is x cube plus x minus 1 equals 0. The base root or the initial root x0 is 1 and the first approximate root x1 equals 0.75, and the iterative formula is x of n plus 1 equals 2xn cube plus 1 upon 3xn square plus 1. In the second iteration, for x1 equals 0.75, the second approximate root x2 will be 2 into 0.75 cube plus 1 upon 3 into 0.75 square plus 1, which works out to be 0.6860 by calculator. We write the third iteration for x2 equals, that gives the third approximate root x3 equals 2 into 0.6860 cube plus 1 upon 3 multiplied by 0.6860 square plus 1. This gives 0.6823 by calculator. Now we will find the fourth iteration for x3 equals 0.6823, which gives us the fourth approximate root x4 equals 2 multiplied by 0.6823 cube plus 1 upon 3 multiplied by 0.6823 square plus 1, that gives 0.6823. Once again on calculator, we observe that the third approximate root x3 and the fourth approximate root x4 are same 0.6823. So after 4 iterations we get the root of this equation x equals 0.6823. Substituting value of x here, it will be 0.6823 cube plus 0.6823 minus 1 will work out minus 0.40666, which is very close to this 0. We will use Newton Raphson method to derive a formula to calculate cube root of n, where n is a positive number. And with this formula we have to calculate cube root of 11. We will start by assuming x equals cube root of n. By taking cube we get x cube equals n. We write x cube minus n equals 0. Here we get f of x equals x cube minus n and f dash x equals 3x square. Now by Newton Raphson method we have x of n plus 1 equals xn minus f of xn upon f dash of xn. This we write xn minus f of xn will be from this xn cube minus n upon f dash xn will be from this 3xn square. This xn plus 1 further will be xn into 3xn square, 3xn cube minus xn cube, minus into minus plus n upon this LCM 3xn square, which will be 2xn cube plus n upon 3xn square. Now this is the required formula to find cube root of n. Now we will estimate the initial root of the equation by guessing the cube root of 11. We know that cube root of 8 is 2 and cube root of 27 is 3. Since 11 lies between 8 and 27, the cube root of 11 will lie between this 2 and this 3. Now we will start by assuming the base root or the initial root x0 equals 2. So the first iteration will be x1 equals from this 2 into 2 cube plus 11 upon 3 into 2 square. This works out 2.25. In the second iteration we calculate the second approximate root x2, which will be 2 multiplied by 2.25 cube plus 11 upon 3 into 2.25 square. That works out to be 2.2243. Third iteration gives us the third approximate root x3 equals 2 multiplied by 2.2243 cube plus 11 upon 3 multiplied by 2.2243 square. This works out to be 2.2240. Hence we write cube root of 11 equals 2.2240, which is very close to the actual root found on calculator, 2.22398. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.